All right, guys, today, this says 9.7, but I think I got the bad copy. I think it's like 9.5 or something like that. But anyways, we're talking about some scatterplots. More specifically, how to describe them using correlation and line of best fit to kind of further understand our, scatterplots. With that said, one thing I want you to remember is we read graphs from left to right. I'll say that a million times, but as we're using these new vocabulary words and definitions to describe these scatterplots, make sure we're going from left to right as we're referencing, if a line's going up, down, whatever. Let's just jump right into these definitions here. Strong positive correlation. Strong positive correlation. Strong meaning the points are very close together. Another way I can write this down, close, I'm also going to say, I think that's how you spell it, smushed. They're very smushed together. So strong meaning the gravitational pull, the magnetic pull is real strong. The points are very close together, okay? They're very smushed. Positive meaning that from left to right, the points are going in upward trend. Now, we'll just learn as we, get through more of this, will make more sense. Weak positive correlation. Weak meaning the points are not going to be close together, so they're not close. And they're gonna be a little more spread apart. So that says not close and spread apart because they're gonna be a little more space between the points, okay? But it is a positive, meaning it's still gonna be going up. There's gonna be a trend of points going up as we go from left to right. And now we're gonna kind of do the reverse. Now we have strong negative correlation. Again, strong meaning the points are gonna be close together or smushed. And because a negative correlation from left to right, it's going to be going down. We have weak negative correlation. Again, weak meaning the points are not close together. And they are going to be spread apart. They're gonna be a little more space between them, a little more spread apart there. And we're gonna go down. Again, from left to right, points are going in a downward trend. Lastly, the fifth one is no correlation. No correlation literally means that there is no pattern. You can't tell if the points are smushed, if they're far apart. Oh, I guess they will be far apart. You'll see what I mean. You can't tell if it's going up, down, anywhere. There's no pattern at all. Real quickly, line of best fit. All we're going to do is we have a couple, we'll draw a couple lines of best fit. Here are the guidelines. The line should follow the correlation, meaning these definitions we're going to identify first. It should, especially the up or downs. The line should go through as many points as possible and should kind of go right in the middle. There should be like almost kind of like equal number of points top and below the line, which is that's rule number 3. So it should be about even number of points above and below the line. And 4, the line should pass through the points throughout the line, not just the beginning and end. You'll see what I mean. It's going to take just some practice with these. We're just going to jump right into it. So I'm going to do this first row of problems right here, this one right here. Now, we're going to tell us the type of correlation, and we're going to draw the line of best fit. So for number 1, well, for number 1, from left to right, this is going down. So it's definitely going to be a negative correlation. Also, my points, I'm just going to kind of draw the line of best fit first, and we'll see what I mean. That would be like my line of best fit. It seems like it's kind of going through a lot of points. There's about equal number of points on top, above, and below this line. And they seem pretty kind of squished to that line. Like all the points are relatively close to this line that I drew through the cloud of points. So I'm going to say this is going to be a strong negative correlation. Strong because the points are kind of close to that line of best fit. Negative because from left to right they are going down. And there we go. That's it. Number 2, if I want to draw a line of best fit through this, I cannot tell if this trend is going up or down. They're kind of just everywhere. This is definitely going to be a no correlation problem. And because of no correlation, I cannot draw a line of best fit because there's no way to even know where the trend of points is actually leading me to. 3. Okay, I got a little cloud of points here. Clearly, that'd be my line of best fit, right? I kind of draw a nice line right in the middle of this cloud of points here. They're about equal number from the above and below or left to right, however you want to look at this. So it is a positive correlation. As far as strong or weak, the points are not as squished to the line like this first one was. They're a little more spread apart. So this is going to be a weak positive correlation. Weak because my points are not as close to that line of best fit. Positive because the general trajectory of these points is going upward from left to right. And there we go. I'm done. Number 4. This one's going to be super simple. Number 4, obviously, they almost perfectly in a straight line already. So that's going to be a strong correlation. And it's going down when we're going from left to right. From left to right, we're going downhill. So it's going to be negative correlation. This is a strong negative correlation. Those points are very, very close to that line of best fit. Number 5, same scenario. We got some more plots here. They're almost already in a line. So it's a very strong correlation because my points are pretty almost nicely in a line. It's also going down, so it's going to be negative again. So a strong negative correlation. Let's do some new stuff. Skip those. Let's do this problem.
Okay, so what we're going to do is we're going to look at this one that's about laptops, the hard drive capacity in gigabytes, and the price in dollars. So first things first, it's asking us what type of correlation best describes hard drive capacity and price. So when I look at this data set, I'm going to draw this best line of fit here in green. And it kind of looks like it goes, all right, and that's pretty nicely drawn best line of fit. Now, this is going to be a strong positive correlation because the data points are pretty close together next to this line of best fit that we drew, and it's going in an upward fashion for an upward trend. And when you read from left to right, if it's going up, that is a positive thing. So the next question asks us, what is the price of the laptop with a hard drive capacity of 8 gigabytes? Well, hard drive capacity is over here. And here is where I find 8 gigabytes. Now, when I look at this line, I see that there is a dot that is already formed here. So what I need to do is figure out that price because that is what the question is asking me. So I'm gonna roll over, draw as straight of a line as possible here. So what number is in between 1,000 and 1,200? Well, it looks like it's gonna be about $1,100 for a 8 gigabyte hard drive laptop. This one's asking for letter C, what is the hard drive capacity of the $1,200 laptop? Okay, so this time it gives us the price. The price here is $1,200. So I'm gonna go across until I find a dot that matches up with this. So here's the dot. Whoop. Okay, so when I go down, the gigabyte that they want us to look at, this gigabyte is 12 gigabytes. So 12 gigabytes. All right, so again, all I did was I started where the price was 1,200 because that's the information they gave us, found the dot, the point that correlates with that, and dropped down to figure out the gigabytes, which is your x-axis. And then what tends to happen to the price as the hard drive capacity increases? So this is a kind of a conclusion problem. What can you conclude about the data? Well, we can say something along the lines of, as the gigabytes increase, which is our x-axis, so as our gigabytes increase, the price increases, right? The bigger the gigabytes, the bigger the price value is becoming. All right, so that's something we can infer, that we can conclude. All right, that's the end of this video. The rest is all you. If you need any more help, go ahead and ask your teacher.